Hi everyone, welcome to the third part of the Game Dev McGill tutorial series. So in this tutorial, we're going to be going over resources. So this is kind of the tentative outline that I presented during the last tutorial. We chose to rename this tutorial from Player Block Interaction 1 to Resources because we felt that that kind of fit the theme of what we're covering this tutorial a bit better. But so this is the third installment, and next we're going to be actually talking about player block interaction. But for this one, just to cover today's agenda, we're going to start by recapping the previous tutorial. Then we're going to be going over creating a resource, creating a player inventory to hold the resources, and then we're going to be creating the resource pickup script, which is actually going to contain the logic for picking up a resource and adding it into our inventory. And then we're going to get into the actual project. So just before we get started, basically the resource in this context is going to be the dynamic counterpart of a block object. So, in the previous tutorial we created a static block game object, static meaning that it doesn't change, it doesn't move. And so basically what a resource is going to be is when we, destruct or we break a block, and it's going to drop resources that we can pick up resources anywhere in the map, and that's what we're going to be using to actually create new blocks in our scene. So in Minecraft we had they have like wood resources that you can pick up, coal, gold, diamonds, things like that. So each resource is going to be associated with a specific block that resource can be used to create that block. All right. Next, obviously, we need to be able to have some kind of inventory to hold all of our resources. So we're going to also create a player inventory. So on the right here, I have some pictures of some examples of some inventories you might have seen. Specifically, this Minecraft one is going to be kind of the one that is most similar to the one that we're creating. But in this one, we're going to make a very simple player inventory. It's basically just going to be a hash map or a dictionary in some languages, where basically we're just going to map a resource into how much of that resource we have. It's this very simple dictionary inventory. And in addition to inventory, in the inventory class, we're going to expose methods for interacting with the inventory. And you'll see that as we get into it later on. And finally, we're going to create a resource pickup script. This is going to be very similar to what you guys did in the rollerball tutorial when you picked up the little cubes. Very similar logic there. The only difference here is, of course, when we pick up a resource, we want to also add it, make sure that we add it into our inventory as well. So we're going to be interacting with the player inventory in the resource pickup script. So let's just get right into it. So I have here the scene from the last tutorial. So you should have just a player and the block manager that we created in tutorial 2, and we're just spawning here a bunch of randomly placed or I guess a 2D grid with random holes, I should say. This is what we made in the last tutorial, if you guys remember. And we can move our player around and stuff like that. So let's just start by making our resource script. So this is going to be pretty simple. It's going to be similar to the block script. Fairly empty for now, but let's go into the script folder. I'm just going to make a new folder called resources or resource, just to keep everything organized. And then I'm going to create a new C# script, call it resource. Just gonna open that up. If you remember, our block script was pretty much completely empty, but we just had it to represent that, it's kind of just good to organize and keep everything modular, and everything that would be associated with the resource or the block would be in their own scripts. So this one is going to be pretty much empty, but in this resource script, we're actually going to have we're going to add a resource ID field. So not completely empty, but almost. And this is how we're going to be uniquely identifying each resource. And this will come in handy later on when we're creating the inventory in the pickup script. So we'll see that for sure later on, but for now we'll just have this basic resource script. So we have that here, and we're going to now create our first resource prefab. So if you remember last time, we had a wood prefab, wood block prefab. So I'm just going to drag that into our scene. This is what we made last tutorial. For the resource prefab, I'm basically just going to visually, what I'm going to do is I'm just going to duplicate this wood block prefab, and I did that just by selecting the wood block and then clicking Control D or Command D on the Mac, or you can also just right click and click duplicate. So we have a duplicate here, and all I'm going to do is just make the scale 0.5. So it's just the resource, the wood resource is just going to be a smaller version of the wood block. Now, of course, this is going to have the block script on it, so we're going to want to make sure to remove that and add our new resource script. And for this resource ID field, I'm just going to make it wood. So one very important thing to note here is that this wood resource is still an instance of the wood block prefab. So if we were to click apply at this point, it would actually modify the wood block prefab. Obviously that's not what we want to do. We actually want to create a new prefab. So we'll go ahead and rename this just for visibility. We'll rename that to wood resource. And in our prefab folder, we can just create a new resources folder and drag our wood resource into that. So now this wood resource game object is an instance of this wood resource prefab. So if we click, any modifications that we make are applied to this new prefab that we made. Cool. So now we made the wood resource prefab. One thing to note that I kind of mentioned in the slides was that each resource is going to be associated with one block. Right? So if we had a wood resource, it's going to be used to create a wood block, etc. So the way we're actually going to form this link between a resource and a block is we're going to use this resource ID field. So we have this resource ID field in our resource script, but we're going to actually want to add that field into our block script. And if these two resource IDs are matching, that's how we're going to indicate that the block and a resource are associated with each other. So we're going to go ahead and open up the block script. And we're simply just going to add a resource ID field here into our block script. So if we go here now, wait for it to compile, we should have see a resource ID field here. And we want to make sure, because this wood block is going to be associated with this wood resource, we have to make sure that the wood resource IDs are matching between the two. So we can go ahead and do that. Click apply to save the prefab. This is very important, because if we didn't click apply, only the resource ID of the specific wood block instance would be changed. But by clicking apply, we're actually changing, if we go back here, we're actually changing the prefab itself, which is very important. Just to double check, let's go ahead and start our scene. So just to make sure that we did that correctly, if we click on any of these new wood blocks that we're creating, you'll see that the resource ID is already set to wood, and that's because we saved the prefab. Sweet. So now we've made a resource prefab, and we've associated the block with that resource prefab. That's cool. So now what we're going to do is we're actually going to create a player inventory script. Actually, before we do that, let's go ahead and actually tag the resources. So actually, we'll get to that once we actually do the resource pickup script. So like I said, let's just continue with the player inventory. So we've created this wood resource Now we're going to make a player inventory that's going to hold all of our resources. So let's go ahead and go to scripts. We can right click C# script, and we're just going to call it player inventory. Go ahead and open that up. All right, so as mentioned before, this is just the way we're going to be maintaining all of these resources, is we're simply just going to have a dictionary that's going to map string to ints, and we're going to call it resource count map. So you might have noticed that we're not mapping resources to ints, we're mapping strings to ints. So this string is actually going to be the resource ID that we added to our resource. So this is another benefit of just using that ID here. So I want to make sure to create a new instance on start. Sweet. So now technically we could be done here. One way we could use this is that if someone wanted to add a new resource into our dictionary or remove a resource in our dictionary, they could access the player inventory directly, get the dictionary directly, and then modify it. But that's, general object-oriented programming practices says that that's probably not a good idea. We probably want the player inventory to encapsulate all of the behavior of interacting with our dictionary. So what we're actually going to do is make this dictionary private. We're going to implement a bunch of methods, public methods that anyone can call to interact with this dictionary. So the first method that we're going to implement is going to be called canSpawn. And this is basically going to check if we can spawn a certain block that we're given. So this is relatively straightforward. We can just say, each of the block has a resource ID. So we can just basically check if that key is contained within our resource count map. So just again, remember that this resource count map is taking in a string and it's mapping it to an int. So obviously if we don't have a resource in that map, then we obviously don't have it in our inventory. So all we're checking here is that if we're just basically checking if the resource associated with that block is contained with our resource count map, then we can spawn it. If it's not contained within our resource count map, then we can't spawn it because we don't have any of those resources. Next, we can have a simple method called onResourcePickup, where we can give it a resource. So this method can be called when we pick up a resource. So basically, if we want to add a new resource into our count map. So all we can do here is we can fetch that resource ID from the resource. We actually want to make sure that if it's not if the resource is not in our resource count map, we actually want to initialize it to 0 to begin with. So we can just simply do that by checking if that key contains key ID. So if we don't have that ID, we just want to initialize it to 0. And then, in the usual case, if we already have it and we've already initialized it, all we do is just increment that value. So remember, the ID is mapping to an int, and when we pick up a resource, all we're doing is incrementing that count, right? So we've done that. Next, we want some kind of method that is going to be removing a resource, so we can call it like on block. Excuse me, that's not what I meant to do at all. Public void on block spawn, so when we spawn a block. So obviously we want to make sure that we actually are able to spawn. So thankfully we have this canSpawn method here, so we can simply just call that first. Say, can we spawn this block? If we can't, then that's probably an issue. So we want to say something like, make sure to log that So on block spawn called when unable to spawn block. And then we want to make sure to just return immediately after we log that. So if we can spawn, then all we're really doing here is we're decrementing that entry in our dictionary, right? So let's say resource ID minus minus. So you'll notice here as well is we're assuming here that if a resource is not in our resource map, then it's completely not in our resource map. It doesn't map to 0. It's actually completely not within our dictionary. So we actually really have to be careful here, because if we were just to simply like say we have 1 wood resource, and then after calling this, we would decrement that to 0. If we called can spawn, this would actually return true, even though we only have 0. We have 0 wood blocks, wood resources. Excuse me. So what we want to actually do is we want to make sure that once we hit 0 of a resource, so if block resource ID is equal to 0, we want to actually make sure to remove that key from our dictionary. Of course, in this method, we could have just checked if it's, if it contains the key and the value is greater than 0, and then we wouldn't need to do this. But just, just so we don't have a bunch of garbage laying around in our dictionary, let's make sure to actually just remove that key from the dictionary once it hits 0. Sweet. So now we have this inventory. Make sure that we don't get any compile errors. Looks like we're good. So we can go to the player and just add the player inventory. And of course, you can just drag the script onto the inspector panel as well to add the component to the game object if you'd like. But okay, so now, if we run our game, obviously nothing interesting is happening here, because we just have an inventory, but we have no way of actually interacting with that inventory yet. So what we want to do is have the player actually pick up resources, of course. So we're going to actually create a new script. This is going to be our resource pickup script. So we can go ahead and open that up. Cool. So obviously this resource pickup, it's going to, basically 2 things are going on here. First of all, it's going to maintain logic with actually picking up resources, so checking if we're colliding with a resource and then picking it up. And we're also going to want to interact with the player inventory that we created to actually add that resource into our player inventory. So we want to add a new field here, which is going to be basically our player inventory, a reference to our player inventory. And we're going to want to get that reference on start. Just inventory. Okay, and we can just simply call get component player inventory. Cool. So one thing to note here is if the game object does not have a player inventory, if we forgot to add one for some reason, this will actually return null, and this reference will be a null reference, which is obviously not what we want to do. So one way to make sure that we have a component on that game object is we can actually go ahead and above the resource pickup, above the class declaration here, we can actually say require component type of player inventory. And what this is basically saying is when we have this resource pickup, when we a component onto a game object, it's saying that this player inventory component is actually required to also be on that game object. So that's really cool, because if you go back into Unity, I'm just going to have a demonstration here. You don't need to do this, but if I go back into the player and I remove my player inventory and I go ahead and add a resource pickup script, let's go ahead and let me do it this way, resource pickup. It's going to actually also add a player inventory because it's a required component of the resource pickup component. And you can read about more about that on the docs if you'd like. Sweet. So we have that. We have a reference to our player inventory. So now we actually want to have the logic of, when we collide with a resource, we want to pick it up and add it to our inventory. So this is shouldn't be too new to you because you guys worked through the rollerball tutorial, and this is basically the same logic. So we're implementing this on trigger enter method. So we're going to say if we're going to use tags here, and like I mentioned before, we actually didn't change the tag on the resource, but we'll do that after this. But we're going to say if the tag is a resource. So what do we want to do? So we want to call our inventory. We want to add that resource into our inventory. So we can call our, what did we call it here? On resource pickup, and simply pass the resource component into that method. Remember, we're given a collider, so we can't just pass that directly into the on resource pickup because it's expecting a resource. So we have to call get component, and that would fetch the resource component associated with that game object we're colliding with, and then pass it to on resource pickup. And then after, we of course want to destroy this game object. So once again, make sure that you're not calling destroy only on this other, because that's just a collider. It would only destroy the collider associated with the game object that we're colliding with. We actually want to destroy the game object that the collider is associated with. Cool. So that's pretty much it in terms of the collision logic. But there's things that we need to do in the scene now in order to set up the player resource collision. So if you remember here, this method is actually on trigger enter. So we're assuming that we're colliding with a trigger collider. So one change that we need to do is that we have to go to the resource object, and we actually have to tick this is trigger check on the box collider of the wood resource, and we can just click apply. So now this resource prefab is a trigger collider, so it's going to allow this method to be called. In addition, however, our player also needs a collider, because obviously in order to detect the collision between two game objects, each game object needs to have a collider. If you go to our player, we actually don't have a collider as of now, so we need to add, we can just add a simple box collider. You can add maybe like a capsule collider, whatever you like. You can use these center and size parameters to actually make sure that the collider fits well around your player. I'm not going to spend too much time on this, just for the sake of time. That should be good enough for now. But of course, you can go ahead and take a lot of time to make sure that that fits the box, the player correctly. But yeah, that's pretty much it. So just to recap, we made sure that the resource collider is set to trigger, so we can actually collide with it, and the on trigger method is called. And we made sure to add a collider onto our player game object. So theoretically, if we click play now, we should be able to collide and pick up this object. Oops. Sorry, let me just make sure that we've actually added the scripts onto. Oh, yeah. One thing that we completely forgot to do was make the. Remember, in our on trigger method, we're checking if the the tag of that game object is set to resource. So we've actually forgotten to do that here. So we want to go tag, add tag, and I already have a resource tag here. But how you would add a new one is you click this plus button, type in resource, and then save. And then if you go back, we can just make sure to set the tag of the resource to resource, and then we click apply, of course, to make that saved into the prefab. And now, if we go back, we can pick up that resource. And theoretically, it should be added to our inventory. Now, one way to check that is we can just basically display every time we pick it up. We can have some kind of debug method that will actually print out the contents of our inventory. So I'm going to go ahead and do that. You don't need to, but it might be nice for debugging. So how we're going to do this is we're going to have a method called log resource count map. And basically what we're going to do is we're going to loop through every entry in our dictionary. So in C#, if you like this, don't worry too much if you're not exactly understanding what's going on here. This is a lot of C# syntax. So if you're curious, this is a for each loop. So we're looping through every entry in our resource count map, and that entry is of type key value pair string int. That's kind of a C# detail. You can definitely feel free to look into that if you want to learn more about it. But basically, that's how we're going to loop through every entry into our dictionary. And we're going to log the key, and we're going to log the value. Sweet. So now we can just call this method after we spawn and after we pick up. So this should print out all of the contents of our inventory. So go back into C, make sure everything compiles. Looks like we're good. So I'm just going to go ahead and maybe duplicate this a bit. Okay. Go back into the scene, console. And now, as you can see, every time I pick up, it's going to print out all of the contents of our inventory. So obviously we're keeping track of all the so it looks like we're successfully keeping track of all the resources we're picking up, which is good. One thing that I should mention that's kind of unrelated to this tutorial, but that we forgot to mention in the first tutorial, was if we go to our player, let me just force this behavior by deselecting this as a trigger. You'll notice that our player, how we were doing the movement, is we had a rigid body component on the player, and we're basically changing the velocity of that rigid body in order to move our player around the scene. A rigid body component in Unity is basically added to when you add a rigid body onto a game object. Excuse me, let me just, this is the solution of the thing I'm trying to get to, so I'm just going to uncheck that so you can see the problem. When you add a rigid body onto a game object, that game object will actually behave as like a physically real object. It will actually have like forces applied to it. So if you like collide with something, it'll have forces applied to it and it'll change the velocity of the object. So in certain games, this makes sense. You know, if for example in the rollerball tutorial, you're rolling a ball using physics. You're applying a force and causing the ball to roll. For the player, this doesn't really make sense because, you know, if you imagine it being a cube in the scene and you like strike the edge of the cube. So let me just demonstrate this. You know, if our you'll notice here let me just restart that. So this is represented as a cube, right, as a box in our collision system. So when we actually collide with something, let me make sure to uncheck. When we collide something, it's actually going to apply forces onto our game object, which is obviously not what we want to do. So one solution to this would be to use a character controller. But you know, since we've already decided to use a rigid body, a solution that you can also do is just to freeze the rotation. So what you want to do to make sure that this doesn't happen is go into our player, and these would be unchecked for you, but you would basically want to go to rigid body and select freeze rotation. And what this is basically is going to say is that we don't want forces applied to our rigid body to change our location, our rotation. So, sorry, I'm just gonna raise this up. So if we go ahead back into the scene, you'll notice that we no longer get this issue. Just to demonstrate again, if I uncheck this, it's going to collide and that forces will be applied. But if we freeze it, then that will no longer be the case. So moving forward, since we've added a box collider, this wasn't a problem before in the first tutorial, because we didn't have a collider on our player, but now that we have added one, you want to make sure to make that change and freeze the rotation. But that's pretty much it for this tutorial. So just to recap, we've made a resource prefab with our resource script here. We've added a resource ID field onto our block script in order to associate a resource with a block. We've also created a player inventory script, which will allow our player to keep track of the resources that they're picking up. And of course, we have the resource pickup script, which is actually implementing the logic of picking up the resource, which we can see here. But yeah, that's pretty much it. So thank you all for watching, and in the next tutorial we'll be going over player block interaction. So hope to see you there.